Howdy, YouTube. Okay, so today we're going to be talking about AI and how it works. Sometimes I hear people talking about how, scientists, we don't even know how AI is truly working. We don't even know really what it's doing. And that's not entirely true. And we'll go ahead and take a look at really what's going on under the hood and why they kind of say it and put it in that way. So here are the different areas and subcategories of artificial intelligence. So AI is really the big overall arching topic, and that goes back decades. It's really anything that tries to mimic human behavior. Then we have a smaller subcategory, machine learning, and that has to do with more so like statistical models that are kind of on steroids now that they have access to big data. And then the topic that we're really going to be diving into is deep learning. So deep learning has to do specifically with neural networks. And the most powerful AIs that we're seeing coming out today, ChatGPT and generative AI, image generation, those are all using deep learning neural network models. Okay, so this is a basic neural network. Okay, so in this, we can see it's given two images. It's either going to be a dog or a cat, and then its job is to detect whether it's a dog or a cat, and it's a dog. So really, that's all that's really going on. You have an input layer, hidden layers, and an output layer. So yeah, again, this is just the most basic neural network. This is really all that is really going on at a most elementary level. Okay, so let's get a little bit more detailed. Okay, so here's an example. So let's say we have a handwritten drawing of the number 3, and we want to be able to detect that it's the number 3. Okay, so how would we do this? How would we use a neural network to accomplish this? Okay, so basically we have to turn this image, this black box with the white 3 inside of it, into numbers, because computers, they only understand numbers, right? So how would you do that? Okay, well, each pixel in a computer screen, it's basically RGB, red, green, and blue, and a combination of these three to get whatever color, to get all the colors that we can see in a computer. Okay, and then so using these numbers, we can break it down into those three numbers and then input that into the input layers, the input nodes of our neural network. So in the top left, you can see RGB, let's say it's 50, 255, 255. Okay, those numbers we would put into pixel 1. And then for pixel 2, whatever that color is, we would put into pixel 2, and then so forth. And then so that's how we can basically convert this image into numbers. And then it would go through all these neural networks, hidden layers that that aren't really in this diagram. And then out on the outcome, you have 10 outputs. And then so hopefully it would come out as the number 3. And we could see training in the next slide. Okay, so just some terms. So inside of each node, there's a number, okay, right? Everything's numbers, okay, and that's called the activation number. And that's basically a weight. It's basically how important is that node to the next node. And then each connection between nodes, or each edge, is also has a weight. And that weight, the greater it is, that also dictates how important that connection is from the left node to the right node. And then these numbers, these weights, are going to change and adjust such that it will hopefully at the end be able to light up the correct node on the very right, on the output node. Okay, so here, another example, let's say we have the number 2, let's say we're trying to do image detection again, and let's say this is a kind of like an untrained neural network. And basically, we can see on the very output node on the right, that the number 2, it's supposed to be a number 2, but then the activation number that it produced is a 0.2. What we actually want is that to be as high as to 1 as possible, and we want everything else to be as close to 0 as possible. So right here, it thought it was a 3 or a 6. It definitely didn't think it was a 2. So we have to train this neural network. Okay, so how do we train this neural network? How do we train AI? So we have to tell it, hey, you were wrong. It was actually supposed to be a 2. Okay, so on the very right, you would see, hey, it's supposed to be a 2. That's lit up. So, hey, you were wrong. It's a 2. And we want to nudge, basically, the 2 to be a greater number. So we tell it, hey, 2, we want you to be like, let's say we want you to be a 0.3 or a 0.4. And then everything else, we're going to make it smaller. Like 3 has to come down a lot. 6 has to come down a lot. 7, 8, 9, those don't really have to move all that much. And we're going to change these numbers. And then by adjusting those numbers, it's going to, through some math, through what's called back propagation. So using the back propagation algorithm, it's going to say, hey, if we want the output to be this, what we told it to be, nudge it in a certain direction. Well, then it's going to have to back propagate and adjust the weights of those connections and of the activation node numbers in order to get the numbers that we told it on the right, what we wanted it to nudge it towards. And then so it will slightly start to adjust, and it'll start to change the weights and those numbers until from right to left, and through that adjustment, it will start to train itself to have the numbers that we want. This process is called gradient descent. So in our most untrained model, let's say it's at the top of this hill and this valley, and then by nudging the numbers through training, through hundreds, thousands, millions of iterations, we're going to nudge the numbers to be throughout the whole neural network, all the activation numbers, all the connection numbers. We're going to nudge them such that it will start being trained to produce the output that we want. And this is called gradient descent. So we're going to start walking down this gradient descent. And then we're going to keep getting closer and closer and closer to a trained network to be accurate. And then so at the very bottom, that's when it would be correct in our desired outcome. Again, we want a 2 to be as close to the number 1 as possible, and we want all the other options to be as close to 0 as possible. And then that's a trained neural network. And really, that's how it can do. AI can be used to make anything. Okay, so let's take a look at a slightly harder example. Okay, so AI to play video games. It can play the video game Mario Brothers. I remember I played that one when I was a little kid when it first came out. I never beat that game. It was really hard. Okay, so how would that work to be able to beat Mario Brothers? So how that works, again, Mario Brothers, it's each state. So let's say this state that we see on the screen right here, this is the state that the game is at, and we would take, again, all those pixels that are represented on this screen, and then input that into the input layer of the neural network. And then again, it would propagate, and then on the output layer, it would highlight or pronounce the buttons that are available. So on the original Nintendo, it was A, B, up, down, left, right. Those are the only buttons that were available on the original Nintendo. And then so let's say you were to push. Okay, so in the game, the objective was you want to get from all the way to the right, from left to right, where the castle was. You would hit the flag and you'd beat the level, and that's how you win. So going right is obviously a good thing, and dying is obviously a bad thing. So let's say you were to hit the button. Let's say the neural network said hit the button left. Well, you're not moving the screen, so you would say that's not that great of an input. We're gonna the reward system is gonna deduct you. So there's something called fitness. So you can see that at the top, and then we're gonna say we're gonna punish it a little bit, and then so the neural network will then use gradient descent again to say, hey, that was the bad choice. Let's go do something else. And then let's say you were to hit up, and then you died. Okay, that's like that would be this is called reinforcement learning, and then so that would be like a negative 50 points because dying is really bad, right? You definitely can't die in the game. Okay, and then let's say it's getting trained some more, and let's say it hit A and to the right, and it got a mushroom. Okay, so that's good. So then you would reward it. And then you give it like plus 10 points, and then it wouldn't move as much. So basically, that's how you can use AI and a neural network to play the game Mario Brothers. So we looked at a lot of simple examples. The basic hello world of being able to detect numbers. Mario Brothers, that's kind of child's play now. Now that we see what we can do with ChatGPT and generative AI. So the examples that we went over are super simple. It gets really complicated, guys. These neural networks now are just getting massive. So here we can see there's different types of neural networks, and you would want to use different types for kind of what you want to accomplish. So recurrent neural network, that RNN, that's more for like text generation. Then you have CNN's convolutional neural networks, that's for image detection. You have all these different options, again, based on what you want to do, and picking one, and then just how many layers are inside of them, and how big they are. That even becomes an art form. So it can get really complicated really fast. But again, now guys, you know what the basic mechanisms are for how all this AI stuff works. So yeah, thanks for viewing my channel, and don't forget to like and subscribe.